Thanks very much. This says now hack Barry. It doesn't say now hack Mark, by the way, even though we're presenting together. So I'm going to talk about something that's somewhat more abstract than the nuts and bolts that Barry has demonstrated so ably. And first of all, thank you for the opportunity to be here and talk to you all. And it's really nice to be in a conference where, wearing my usual t-shirt, I'm one of the best dressed people here. So I'd like to talk more abstractly about why physical security is important, and in order to do that, I need to define it. And it really involves access to tangible assets, or the artifacts that represent them, or the access to them. So, you know, it can be a whole range of assets that are not normally considered to be such. People are assets, and computers, the network plugs that you can plug into, your telephone switch, the keyboard interface of a sysadmin, an unencrypted backup tape, or an entire set of backup tapes. Keys on the floppy disk, hardware keys, for example. The list of code names for the deals in play. Personnel database, which can enable you to steal the identity of an employee. The access control computer that lets you into, that decides if your badge is valid for that door at that time. Maybe the master key in the coffee cup of the facilities guy. A clear view of the safe dial, which can be videotaped, can be turned into access to the safe later on. And of course, the money or the bearer bonds in the safe. So we can talk about physical security at lots of levels, from a very high level, security on planet Earth, perceptions about which have become really elusive since 9/11. The contortions in people's decision-making process have become visible to almost anybody who's been through an airport in the last several years. The problem is you can't economically secure anything large against a determined adversary who has assets, who has substantial resources at their disposal. And people are not rational when they make these investment decisions about security. So the politicians, who are salespeople fundamentally, try to grab land and use the fear cell to persuade us that security is more important than other things like freedom or privacy. And we've never really thought about these trade-offs. We as a public have never thought about these trade-offs deeply, so we really don't know how to react to these fear cells. At a lower level than 50,000 feet, in the business environment, there have been some nasty trends in the last few years that reduce security, particularly the ability to control or audit. For example, initially there was centralization of control and operations, which meant making the wires much longer than they used to be. That was a first bad tendency. It meant you were trusting somebody at a great distance from you. Then we started using outsourcing to external entities that now we have to trust. How do we establish a basis for trust over these people? And now there's a lot of offshore development and operations, particularly customer service is moving offshore to places like India and Canada. And that means that the offshore people need access to all the personal information of our customers in order to authenticate them and act on their behalf. At a lower level even, there's physical security in the enterprise, in the company, which relies on, there are all of these factors which cause problems at that level. There's fragmented responsibility and authority, split among different bureaucracies within the organization, and often split among multiple sites. So these people have responsibilities which might overlap, or there might be gaps between them, and somehow they have to work together. Often things fall into the cracks. Often there's no budget for working out problems with older facilities, even if the problems are recognized. Often the people who do the risk management are insurance mindset people. They think, well, we'll just get insurance to avoid that problem. Often the people who have the functional power to fix problems are low status, or low skill, or blue collar. And seldom do they have the training to actually fix the problems. For example, I had a client where the guy who had all the keys to everything was a vice president. But he wasn't high enough vice president so that he had his own office. He had a cube. And Gaffer's tape to the side of his cube was a key cabinet that had all the keys to all the buildings worldwide. So of course I took all of the keys when I did my penetration test. He got an office a few weeks later. Often the decision makers don't have the time or the skills to verify the vendor claims, and it's very hard to test the vendor claims unless you have solutions that are open source, like Bari's, for example. And all of these people and all of their vendors strongly believe in security through obscurity. They don't believe that making evident the limits of the products, their products, and representing accurately exactly what the product can do would benefit their customers. So the common cop-outs you get from these bureaucrats are, that's not my job, which is now turned into, that's my vendor's problem, it's not my problem, even though it's still their reputation on the line if something goes wrong. Or, if they're a little bit more sophisticated, they say, we've never had that problem before, or I don't consider that a plausible threat, as if somehow they quantified the likelihood of it and decided it wasn't reasonable to spend money to protect against it. Or they say, we just have to raise the bar enough so the bad guys go to our neighbors or our competition. I don't have to run as fast as you, as fast as a bear, I just have to run a little faster than you, if you know that joke. Or they say, our controls are better than ordinary locks and keys, and the industry standard is ordinary locks and keys, so we're doing better. That really depends on the value of your assets and how determined your adversary is. Or they say, you have to trust some party or they won't get any work done, or our contract says we have to give them complete access. But my favorite is, but that database is encrypted. Without ever talking about key management or key distribution. So you saw that the 15-pin lock had no more protection than the 5-pin lock against the bumping attack. And this is very reminiscent of the WEP problem, where WEP, 12-bit WEP, if there such a thing existed, has the same strength as 1K-bit WEP because of the reuse of the IV space. Going down another level, we have physical security in a campus or a building where there's a lot of legacy to deal with. These buildings were not typically constructed with security in mind. They were typically made before that and bought, and you move into the building and do as well as you can. So there might be partial height ceilings and hung ceilings which you could go over, or raised floors which you could go under, or wiring rooms out in the hall, or wire runs through the public areas, or networks that are all unsegmented, or previously installed doors and locks which you just try to change the locks on and hope for the best. In a building, you can ask yourself, is there any perimeter, which you can't almost ask yourself with networks any longer because of wireless. You can ask, is there any protected area or vault which you can establish as a basis for trust and put all the wiring and authentication devices in that vault and rely on those for subsequent decision making. Often you have to provide friendly facilities for joint venture partners or visitors or random people who walk in, and they have to be able to work in your space, physically close to you, but they could look at your screen or they could look at your keyboard. Then there are the building networks which control the heating and the air conditioning. Sometimes they control the alarm system and the doors also. And then often there are required backdoors, legally required, or key escrow, for example, a thing called a Knox box. Here's an example of a Knox box. You often see them on the outside of buildings. There's one here which is taped to the, almost taped to a wooden panel outside a door. And inside this box, there's a little a flap under which there's a hole for a key, is a set of keys to your building. So the firefighters, when they get a call saying your building is on fire, they come to your building, they have a key to the Knox box, they open it up, they extract the keys to your building, and then they enter the building without causing any destruction. So what they have in the fire engine is this other device labeled Central Lock on the right. Do you have the laser pointer? Thanks. So the central lock, you don't see the wiring, but it's connected to the dispatching radio for the firefighters. And down the radio link, they send an unlock code, which briefly allows them to take out the key, which opens the Knox box. This is done so that every firefighter doesn't have to have a key to every Knox box in town, and by the way, they are all keyed alike. So this is what I call a single point of failure in an entire town, and these keys are typically 5-pin Medico cabinet locks, which are not difficult to either copy or pick. Not that difficult. Another typical problem with buildings is that multi-tenant buildings weaken the defensible perimeter because they have shared space. They're shared corridors and a reception area and an elevator lobby, and they're probably master keyed, and you have no control over the visitors to the other tenants, and they have their own independent policies, and you can't secure the building as a whole on any level. So what this means is that the tenant's security policy that's the weakest becomes your de facto security policy. If they just buzz people in, well, you're at risk. So co-location facilities like these big server farm rooms in former telephone company buildings are very special cases of multi-tenant buildings. Anyone can rent a rack space in the building, and if they can come in, they can walk up to your cage or your rack, and they can probably touch your equipment. They can allow any vendor to get in to fix their equipment, and that vendor representative, if authentic, could walk up to your machine and touch it. So you end up at risk. It's kind of like being in a gated community where the motorcycle gang moves in down the block. Nothing you can do about it. Finally, we get down to the nuts and bolts level, which is what Barry's been operating on, which is locks, which is the component level where you have locks and doors and sensors and alarms, and somehow somebody has to design something to solve these problems. Now, design, I don't know how many of you ever took a course in design. Actually, how many of you have ever studied any kind of design discipline? Maybe 10%. But you all many of you design software, some of you design hardware. Design is a discipline which is not being taught, particularly in the US. It's not taught as an engineering discipline. It's certainly not taught to security designers. So let's start with doors. What are they made of? Are they single or double doors? Double glass doors often have a gap between them. What's within reach of that gap? Where and of what construction are the hinges? So if doors are simple, how can they go this wrong? Look at all of these things that somehow someone has tacked on the door. This is a fire door. That's the thing that lets you get out in case of a fire. You push it and an alarm starts sounding, but it does open the door. But somehow someone decided to put this double bolt lock on the door, and there's another lock here, and there's another lock there, and there's a sensor and this chain to keep the door. And what's this bolt doing on completely the wrong side of the door? Here's another one. This one has the same, it's another fire exit. It's also got a locked slide bolt here, which will prevent people from getting out in case of a fire, and various sensors and things. And here's a magnetic strike, which holds the door closed with a force of 1,500 pounds. I don't think I want to be on the wrong side of this door when there's a fire. Then we have locks that come in all sorts of forms, and every one of them has one or another kind of weakness. And the locks are mechanical. Maybe they interact with an electric strike or an electrified lock, which releases the lock when someone makes the decision to do that. And maybe there's a computer in which you with a badge reader, and you put the badge against the reader and it decides to open or not. Maybe there are even biometrics. There are problems with the locks themselves. You can't tell just by looking if they're locked or unlocked. So if somebody temporarily has access to the lock and unlocks it, and then you go home but you think it's locked, it might be unlocked. And the dead lockers, the things that prevent the locks from just being opened with a credit card, for example, or a piece of spring steel, are often misinstalled, broken, or ineffective in my tests. I'd say 5% of dead lockers are just not working. then there are often keyed locks on doors that have other kinds of access control. Why is there a keyed lock there at all? They say, oh, if we have a power failure, we need somebody to be able to get through. Well, maybe a building needs exactly one keyed lock for that case. But it's not the case that every lock that has a badge reader on it also needs a key. When you ask them, who has that key? They say, well, we don't know. Nobody has it. A deadlocker is a little device which prevents the bolt from being pushed back. It prevents the bolt from being forced open just with a piece of like a lever, or ordinary lever, or a credit card. Okay. So let's say the door is locked. It's operated by a badge system. Somehow you need to be able to open it. Either you have an emergency release or you have one of these switches called a request to exit switch. This is a mechanical switch. You might say push to exit. Here's an example of a bad one. To exit ring bell between 8 p.m. and 6 a.m. Well, what do you do if nobody answers? You're locked in the building is the implication. These switches are, there's some fine details about the switches. The ones which are compliant with the current Disabilities Act in the US have a very low push strength, which means that if you can get to them from the outside, you may be able to push them with a piece of wood or cardboard or metal. Here's my favorite request to exit switch. It says, please do not touch. Warning, do not touch. It makes you wonder what it's for at all. So here are the frameless glass doors I talked about, which are a problem. Architects love them. The executives love them because they look so open and transparent. And there's a gap. If there was a request to exit switch just inside here, somebody could push something through the gap and trip it. There's a gap here between the two panes. These doors, you can't see how they work. There's an electrified lock in the hinge mechanism, which is activated by a badge access control system. And so these things are normally kept locked, and there might be a badge reader on the outside somewhere, invisible to us. So how do they get unlocked if someone needs to leave? Well, there's a sensor called a request to exit sensor, which looks like this thing. It's a passive infrared device which senses the difference in temperature between a hot object walking up to the door like a human and the background like the floor, and then it opens the door. And these things have adjustable sensitivity and adjustable width, adjustable beam in general, and you can see they have a 20-degree beam width. But if you can put a hot object through the gap in the door and put it in the beam, then you may be able to persuade the sensor that a hot object has walked up to the door like a human, and it will unlock the door for you. Some of these things sense motion instead of temperature, and you can wave a Federal Express envelope through the door and it will open. Sorry about the quality of the graphics. There are two kinds of strikes which hold the door open. The strike is this gadget which interacts with the bolt mechanism. This is the deadlocker, this little, almost impossible to view, half-moon shaped protuberance in the door. It is pushed open. It's pushed to a halfway position when the door is closed. It's in this position right here against the strike. And the bolt, which is exactly this shape, plops into this hole in the door frame. Well, unless the alignment of this bolt works with the electric strike is exactly perfect, the deadlocker is inactive, it turns out. It turns out there's an incompatibility between the biggest selling set of locks in the US and the biggest selling set of electric strikes in the US, where the deadlocker doesn't work at all. Other problems involve exposed, then there are magnetic strikes, which are often not on an uninterruptible power, so you just interrupt the power and the door is unlocked. They're not on battery backup. Often the magnetic strikes are on the wrong side of the door. Adhesive tape on the magnetic strike on the surface between the big magnet, an electromagnet, and a big piece of steel, a plate which is held shut by the electromagnetic, operate according to the inverse cube law. So if you can increase that distance by anything, even a piece of Scotch tape, it dramatically reduces the holding power of a magnetic strike. And then you need those switches, which I mentioned. Often, the placement of the strike is wrong, or the wiring is on the wrong side of the door. Sometimes the wiring is just exposed on the outside. Then there are problems with cylinders themselves, like Barry has demonstrated. You can make a key. Even better, you can make a master key from an ordinary key. There are these kinds of cylinders called interchangeable core cylinders. There's a special key, a control key, which lets you remove the cylinder quickly and replace it with one of your choosing. So you can rekey the lock almost instantly. You don't need a locksmith. All you need is a spare set of cores. Often the control key is much more universal than any master key in these systems. So even if there isn't a master beyond the building, the control key may work for the entire campus. I know of many universities in this situation. And very few lock instances are needed to make either a master key or a control key by disassembling it, or even not. I'll give you a reference to a paper by Matt Blaze on this subject later on. If you can find a lock in a public area or an open padlock, often these sprout legs. You can often make a master key for the entire enterprise. The problem with mechanical locks is you can't revoke rights when you've lost a lock or a master key. So they decided electronic access controls would be great because you could have individual control over which door any person could open, and you could revoke those rights instantly just by turning off their badge. But now there's a computer and a database involved, and there's wiring between all of these components, and there are protocols between them. For example, some of the components are these things called panels, which are physically close to the door and the magnetic strike or the electric strike and the badge reader. And these things have caches of access rights, because if the computer is down or the wiring is broken, you still want the door to allow people to get in. So the cache remembers the last state of badges used at that door, or perhaps in the entire building. So now you have a cache consistency algorithm where if somebody changes something in the database, they have to push the deltas to the different caches and invalidate certain lines of the caches. And you can bet that there are bugs in some of these cache updating algorithms. These panels are connected on local wiring to the badge readers and the doors that they control, and then they used to be connected on local wiring, perhaps a loop in the entire building, to the computer that had the database. But now they're on the network. And guess what? They don't use mutual authentication of the counterparties. They don't use challenge response. Almost all the communication is just TCP or UDP in the clear. No sign-on, no passwords, no sessions, nothing. Not even serial numbers in a lot of these protocols. And all of these people have invented their own protocols. Many of them built products that were connected on RS-232 or 485 local wiring, and then they had the market demand to network enable their product. So how did they do that? They bought a terminal controller, a standalone terminal controller, which on one side has a serial port, and on the other side has an Ethernet, and it's the moral equivalent of a connector, a transformer, an adapter. It doesn't really do anything. You telnet to some port, and you're connected to the serial port. Often these things have no access lists, no IP filtering, no passwords, or even worse, they have default passwords which nobody ever changes. At least they don't have sniffers built in. And most of these devices have backdoors for installers and maintainers which are undocumented. Default passwords, default logins, or sometimes they're documented in the installation manual, but the customers don't know about their existence. And what about those cards that you hold up to the doors? Those cards are primitive examples of modern RFID tags. They have a subnetted, they basically just have a number on them. Sometimes it's a 32-bit number. Modern ones might even have 64 bits. But this is subnetted into a facility code and a card number. and the facility codes are not really controlled. So if you know that somebody is facility code 3294, you can go to a manufacturer and say, hey, I'm facility code 3294, can you send me badges 1 through 100? And they'll do it. They won't ask you anything, you don't have to prove anything. Many of these cards are field programmable, so you can put your own facility code in. Most use no challenge response or any kind of authentication. So I figured somebody must have built a card reader and a card emulator that would replay this, and sure enough, I found an undergraduate at a university who did it a couple years ago. I'll give you the reference later on. Most of these things can be read remotely. All you need is, the equivalent of a badge reader and a battery and a PIC-based recording device, and you can walk up to someone in the elevator and read all the badges in their wallet. Or you could install it at a banquette at the luncheonette in the financial district, and then follow the guy to work, figure out that he works at Goldman Sachs or something. The low card numbers are more likely to be senior, given to the early employees, and more privileged. But that hardly matters if you can read any card. You can do brute force attack on the number space. Since none of these devices ever expect a brute force attack, they will log all the failures, but they take no countermeasures, like lockouts, like exponential backoff, or anything. It's like Unix login in 1960. So are these more or less secure than keys? It's very hard for me to decide. Instant revocability gives you, and fine-grained access control, you can limit it to an individual door, are big advantages, but this kind of a class attack on them makes them very risky. So here's a case study that I did with Mark Chen a couple years ago of a Receptors GP3. Receptors is a company that makes these access control systems, and we found one in one of our financial data services company we were auditing, and we were doing a complete audit, physical security, network security, social engineering, everything. So we found the badging system, and I thought, great, can I make a badge that will let me get into anything? No problem. They plopped their SCO Unix machine on the network with non-standard addresses, but it was still on the normal network. They had serial wiring to the guard stations, so-called guard stations, which were at the reception desks in the various buildings, which were running terminal emulation on PCs, and they were running TCP to the panels in the various buildings. The root password was published in the user manual, R00T. Well, that was helpful. Of course, first I had to pick the lock on the door of the badge making office so I could get in and get to the console of the thing, but that wasn't that difficult. There was a dial-up modem, which Receptors tech support said, oh, we think that should always be left on because they could have a problem. I asked them, how many people changed the root password? They say, oh, we don't think that's a good idea because then we wouldn't be able to support them. So I logged in as root and started poking around, and I noticed that there were all these ports the thing was listening on, and all the source was on the machine for the convenience of the vendor, because they had ifdefs, and they would compile different versions of the code for their different customers. So I started looking at all the ifdefs, ifdef Jetway, ifdef US House, ifdef LDS Church, that's the Mormons, AMD, who makes those wonderful processors, General Electric, University of Washington, Corning, House of Representatives, I already said, Senate of the US, University of Southern California, Yale, 5 airports mentioned by name. I was feeling great. I realized I could have, well, no, I didn't want to change the software of any of these customers, but I could have because I had their source code. It turns out their customers included more than 50 airports, the entire state prison system in one US state. I was visualizing musical cells. At midnight, open all the doors for 5 minutes and see what happens. Courthouses, even a US spook agency. I thought I should tell the spook agency, and that is a separate story, which I will tell you over a beer. So I looked at their database schemas and their tables, and that was really interesting because the system has this concept of passkey. Metaphors are powerful in security. So, and guards understand about passkeys. You say the magic word and it lets you in. Okay, so there was a passkey which lets you be a guard. There was a it's really like a password without a login. So you knew the right word, you could be a guard. You knew the right word, you could be the system manager. And all of these things were stored in a table lightly obfuscated. You know, the moral equivalent of ROT 13. So, looking at the passkey validation code, we noticed there was this undocumented feature. If you typed in a number, the right magic function of today's date, it will let you be the system manager. This was not in the manuals anywhere. Nobody knew anything about it. So of course, given that, you could become the system manager on a dial-up line, or you could enable or disable badges. You could do the magic cells thing that I mentioned. You could cause immediate diagnostic events to occur. You could even create stealth badges, which had unlogged access. And the reason for that was because of a misplaced right curly bracket in the logging code, which we noticed, because it was looking up the badge, and if it didn't find it in some table, then it wouldn't log the lookup. It would go on and do some other check, which had to fail before it would do the logging. So we could create special badges in the database which had special powers and could do things unlogged. All the code downloads to the panels, the badge controllers, were stored on the Unix host. They were unsigned. Of course, they had CRC codes so that integrity would be guaranteed before doing the update, but no signature, no cryptographic signature. We could also disable the logging mechanism and nobody would notice. The fact that the logging mechanism was disabled would not be visible to any panel. It would just spill its events and then erase them. So if you briefly disabled the logging mechanism, those log events would be gone. So the vendor in this case was just as much in denial as in Bari's case. They accused us of using unfair tactics in reverse engineering their system. They said that a maker of barbed, I believe I'm quoting this guy almost verbatim in some magazine. He said the maker of barbed wire should not be pilloried when someone leaves the gate open. I didn't even understand the metaphor. Okay, so another thing you have to worry about is sensors and alarms. When is sensed movement in a protected area an alarm event, and when is it just normal? The problem with badges just on the outside of your door is you can't tell if movement in the event is a normal case or an alarm event. The only way you can do that is by forcing everyone to badge in and to badge out and counting the occupants that remain in the space. And when the count goes to 0, in that case, any movement in the space is an alarm event. Usually, the alarms are not integrated with the presence systems or the environmental systems or the badging systems, making this kind of design difficult to implement. So if you can trip these sensors from outside the protected area, you can do all sorts of things. Aside from opening the door using the request to exit sensor, you can also cause nuisance alarms. And I think Ross Anderson has measured how many nuisance alarms are typically responded to by an agency like a police department or an alarm service. I think it's something like 2.5, and then they give up. And then they say, oh, there's something wrong and we'll fix it in the morning. And all alarm events after that are ignored for the rest of the night. This is a social engineering opportunity. So sensors are wired to the control elements, usually in a closed loop, and the wiring can be manipulated as well. And often these wireless sensors are battery powered, and the wireless protocols they use are extremely naive, because they're much more concerned about battery consumption and installability than anything else. They're like garage door openers, and they're more like garage door openers in their sophistication than like crypto components. Video is another double-edged sword, because the bad guys can use video to photograph you're moving the safe dial, or you're typing your PIN in, or you're typing your password in. But you can also use video now, cheap USB cameras, to detect the guy from the co-location site coming into your cage and opening your rack when he's not supposed to be in there, or anyone opening your rack, right? Why are they doing that? Concealed video is ubiquitous these days. You can get video cameras and things that look like ordinary household items of every kind. You have to get the video right or you won't be able to use it. And that is an optical problem with lenses and coverage areas and all that stuff. Plus, you have to be able to search it once you've recorded all this video, especially if you don't know exactly when some event occurred. I'm not going to go into any more detail on this. So here's a colo case study. I'm persona non grata at this very famous large colocation site and all of its many tentacles because I succeeded too well in breaking in. It's a very large facility, bigger than a football field, with vaults and cages and cabinets on the raised floor, and all the common data wiring is overhead, and all the raised floor is the plenum for the cold air, and that's where the power is. Heat is the biggest problem right now in colocation facilities, heat and power, not communication. Joey Ito told me that the Japanese power company has a big advantage in supplying colocation facilities because they have cheap power, unlimited amounts of it. So the facility issued their own anonymous-looking prox card credential in a proprietary format. You could still read it, but you couldn't order these easily. The cabinets that were out in the halls had wafer locks in common areas, which were a joke. They could be picked in less time than 3-pin wafer locks. So anyone who was how about turning off the cell phone and being here? Okay. So anyone could pick it and open your cage for you. The cages themselves only went up a little bit higher than I am tall. There was video, partial video, but the secure place, this was their excuse for existence, were these vaults. And the vaults had video pointing at the front door, hand geometry readers for the entry, electrified locks, a door open magnetic switch in the door so they could tell if the door was being forced, and a motion detector just inside the door. I thought, okay, well, that might work. But the vaults themselves were really prefabricated structures with 4 walls, and the floor was still the raised floor, and the ceiling was still the dropped ceiling. So you could enter through the ceiling, or you could enter through the floor. I thought that was an opportunity. First, I had to get in the building. That wasn't very hard. You need some concept of identity for these controls to work well, so the fact that they issued their own credentials seemed to me to be pretty strong, because anyone can make something that looks like a driver's license. It's nice that the credential somehow conveys the right to do something, rather than, a driver's license being a de facto identity document in the US. Not only does it convey your right to drive, but it also says how old you are, talks about your right to drink, might have your social security number on it, might have a thumbprint. Why is all that crap there? Originally, it just said you had the right to drive, and that's what it's for. So the fact that all of these rights and responsibilities are being overloaded on a single document is a big problem, because it means that the bar can check your ID and steal your identity. So here's the thought question at the bottom of the screen for you to think about. Is it better for your colo to accept your driver's license or to issue you their own credential containing a shared secret with them, or to check your face in a database? So there were a few months that pointed to identity theft as a big growth area. There's this guy, Abraham Abdullah, who stole 80 of the 400 richest Forbes identities and opened accounts in the names of Paul Allen and Tom Siebel and all these, lions of industry in the US. This was detected when Siebel was in Davos at the World Economic Forum, and he got a call from his broker who said, Paul, your account is out of balance with its investment objectives due to that purchase of a house in Switzerland. He said, what house? And they managed to undo a large wire transfer in record time. I thought that was very hard to do, but they managed to do it. The same month, VeriSign issued some Class 3 code signing certificates in the name of Microsoft Corporation to parties who have never been accused of, never been apprehended. And at the same time, the General Accounting Office in the US reported that you could buy assault weapons using phony driver's licenses. So I started, when all these things happened in the same week or two, thinking that identity was an important issue. I actually looked into the buying of a weapon thing, and I discovered that you fill out a form, and it asks you questions like, are you a fugitive from justice? Are you an unlawful user of or addicted to marijuana, or etc.? Have you been adjudicated mentally defective? And if you're mentally defective enough to answer yes to any of these questions, you won't get a weapon. But they check your driver's license. They check it against a database. And if you were unlucky enough to make a phony driver's license in the name of a known felon, you will not get a weapon. They do not check that your driver's license is authentic or that it was ever issued. Of course, everything you need to create identity is available on eBay. Here's what I bought. And here's what you can buy if you make your identity. This is bought by the General Accounting Office, not by me. So, physical security, this is an entirely different dimension of physical security, you know, the guns and badges kind. But these are scary devices which you've doubtless run into. They're keyloggers. They work on PS2 interfaces, and they store up to 2 megabytes of keystrokes. Everything you type and backspace over, having had second thoughts about it. It's the closest thing to thought control that there is, thought recording. It will record your dreams and your intentions, even if you think better of them later on and you don't send that email. They cost less than $100. So if someone has momentary access to your PC keyboard interface, they can install these, and you probably won't notice it there. Or they can install a keyboard with this built into it, inside the keyboard. But then they have to come back and retrieve it to get your keystroke information. So we knew about tempest shielding, and now we know about the keyboard interfaces, and somebody told me about looking at power attacks on the LEDs on the keyboards, which would enable you to determine things like keystrokes and disk data written. I didn't know about that one. But these 2 guys at IBM Research in Almaden, Dmitry Ozanov and Rakesh Agrawal, discovered that you could record the acoustic signals off keyboards. And the template of the keyboard is like a drum. It has a distinctive sound to it. And by doing the right kind of digital signal processing, you could decode with a high probability which key was pressed. And you could even do that across a telephone connection. I'll give you the citation to their work, which is very impressive and suggests many possibilities. So it was suggested that by recording the sound of a dot matrix printer, you could figure out what was being printed a while ago. They also did some experiments on telephone keypads and ATM pin pads, which they could recognize with modest reliability. Not as good as a keyboard. So here's the acoustic signal of the keyboard. There's a little signal when your finger touches the key, and then there's a big signal, that's this, I think. And then there's a big signal when the key touches the plate at the bottom of the key. And it turns out many of these keys sound different. So what they did is they did formant extraction, a pretty naive formant extraction on this signal, on these acoustic signals, developed a normalized FFT, and then they fed it into a neural network. And just so that there's some science in this talk, I'll explain to you what this is. This is 30 keys. They trained this individual keyboard, the neural network, with this specific keyboard, and then they tried keystrokes of Q, W, E, R, and after training, 9 times out of 10, the Q was suggested as the first likely candidate when they pressed a Q after training. 0 times it was suggested as the second alternative, and 0 times as the third alternative. The W, 9 times as the first alternative, one time as the second alternative. So you can see that the recognition of E is quite weak. It was not. For some reason, it didn't produce a distinct signal. But the R and the W and the Q and the T is perfect. You know, most of the time, either the right key was suggested as the first possibility or as the second possibility in any given sequence. The average depth of the correct sequence was 1.99, less than 2. So if you could record a trained keyboard acoustically, and this was done at a distance of 1 meter with an ordinary PC microphone, you could reduce the key space of the passwords by quite a lot if you wanted to do brute force search on the remaining key space, for example. This worked just as well on different kinds of keyboards of the same, not quite as well on, you know, if you have a Dell 300 keyboard and you had 2 other examples of it and you trained it on one instance, it kind of worked on the other 2 instances, but not quite as well as if you trained it on the actual keyboard that was in use. It didn't seem to matter who was typing. It didn't seem to matter if they hunned and pecked, if they typed rapidly. So what solutions do we have to this? Well, you could mute the microphone. You could make people authenticate when they're offline. Most of the solutions involve telephony integration or keep people away from your keyboards or don't use keyboards or silence the keyboards. One interesting alternative, there's a patent which was filed, which sensed people's eye motions and they would move their eyes and look at the right thing on the screen. That was completely silent. That was the way they'd enter their password. Or don't use passwords at all, use tokens, where replay attacks are limited in scope. Other scary devices which involve physical access are unauthorized wireless bridges, which can be installed very quickly, and if you encrypt the traffic, the good guys can't figure out what traffic is being leaked. They might even say, oh, it's using encryption, it must be one of ours. Well, right now, rogue access points have been discovered in many installations, and it's just a matter of time before you notice one. Of course, that 3-digit number on the back of your credit card is readable with momentary possession of your credit card. And by the way, a single DES key is used to verify all of the credit card numbers in a batch. You might think that by now they would understand that they could use random numbers, but no. That would, 3 bytes per card, that must be, at least $10 worth of magnetic storage for a bank. So the real problem are systems are decreasingly designed or built by people who understand their behavior, and the people who make security decisions have no training in analyzing the systems that now have computers in them. And they're much less they're almost untested. You just believe your vendor claims. Don't believe the vendor claims. I won't talk about these trends. You know all about them. All your secrets with you on your Palm Pilot or on your laptop. Here's my Screw the Vendors slide. This is a tombstone from 1870 in memory of Ellen Shannon, age 26 years old, who was fatally burned by the explosion of a lamp filled with R.E. Danforth's non-explosive burning fluid. Well, vendors still produce products that are snake oil today, and the only way to keep them honest is to audit their performance very carefully. Contractually require audits, require them to disclose security flaws to you as their customers, so you know what the limits of the product are. Do independent design and code reviews. Make sure they use employee security as rigorous as your own employee security, and as I said, disclose. So science is not going to solve these problems for you because many of them are people problems, and social engineering problems are very difficult to solve. They can be solved partly by design. Make a design where somebody can't leak a secret because they don't know the secret. They have to get the secret or a portion of it from the customer on the telephone. People will always hide the building master key in the coffee cup. And people will resist heavy-handed authority, so they will ignore security protocols as much as possible. They will also cover up even the most severe of incidents. When I stole all the master keys at that bank, nothing happened. I was expecting there to be a noise, a report, something, somebody would have said something. So I went to my client, who was a senior vice president of the company, and I said, so here are the keys, and I plopped these keys on his desk. What do we do now? Several things we could do. We could go to the guy and say, have you lost a set of keys? Or we could just wait and see what happens, or what would you like to do? He said, let's wait and see. Right decision. A week later, nothing had happened. So we decided it was time to call a halt to it. We went to the guy and said, by chance, did you lose a set of keys recently? He said, yes. I wondered what happened to them. I thought maybe I brought them home, or, well, what did you do? Well, I went to my buddy who has the other set of keys, and I said, Stan, I misplaced my keys. Can I borrow yours? And then I went to the locksmith and I made another set. This is for a different crowd than you. You know all about this stuff. The risks are yours, the reputation is yours. You can't shift the risk onto somebody else just by using an outsourcer or a vendor. It's often cheaper to create compensating controls to detect problems like a break-in than to prevent a break-in in the first place. And this is where obscurity actually adds a little bit of value. If there is some obscurity, somebody might trip your alarms. And you need to have policies in place that are socially appropriate, culturally appropriate, and reasonable, or people will just ignore them. God is in the details. Get somebody on your side, like you guys, who understand what's going on, and point out the problems. Full disclosure is a great thing. Test everything. Healthy level of paranoia is a really good thing, particularly if you can't trust yourself. In Germany, we must quote from Goethe, when at all possible. So here are some references. Here's a quote from it. I can copy a proximity card at least as easily as I can take an impression of a key. So this kid did this Prox card reader replay device several years ago, and there are pictures and pretty complete tools at this URL. Here's the reference to the acoustic emanations talk. Matt Blaze on making master keys and on safe cracking. Matt Blaze is a computer science professor at University of Pennsylvania who's applying an information security mindset to physical security. So you'll find his approach to be very familiar if you do a lot of information security. My door pictures are from the Securitech Gallery of Illegal or Badly Locked Doors, which you can find there. The web is a wonderful thing. You can find almost anything there. And questions now for me or for Barry, or afterwards by email. Please use the microphone if you have questions. And thanks for listening. Oh, I'm sorry. Here are some references of Barry's on, there should be, that's a typo, there should be www.tool, T-O, 3 O's in tool, that's correct, tool.nl. And there's the Vinkhaus press release. Of course, this will be on the website. I'm sorry. Okay. Now you get to see my desktop again. And don't ask me what those files are, please.
Okay, I just got a personal question. How did you get in that job?
How did I get into this job? Well, I've been doing locksmithing since I was an undergraduate because I worked at the radio station at Columbia University in the 1960s, a period of student unrest. And we wanted to report on the kids, breaking into buildings and having demonstrations and getting beaten up and tear gassed without getting beaten up and tear gassed ourselves. So I made keys to the tunnels under the campus and all the buildings so we could just pop up in a magic place and report on it. And since then, I've been sort of an amateur locksmith. But about 10 years ago, my company called Securify started doing security audits, and I said, you know, it's completely ridiculous to ignore social engineering and physical security because the bad guy is not ignoring those possibilities. They will look for the weakest link, whatever it is, and use whatever technique is at their disposal, and maybe they have multiple skills, or perhaps telephony. You know, all of these things are in the grab bag of attackers these days. So we had a much more gestalt security auditing process than the usual checklist or the usual we only look at the network or we only look at the hosts kind of thing. So we really try to understand the process and make attack scenarios. So for the last 5 years, I've just been practicing the complete spectrum of attack and defense.
Hello. I have one question here. Hello. Here. The first one to Mark. What do you think about smoking policies that force people to go through all the perimeters of a company regularly, a few times a day? I mean, it sounds like a bad idea for me.
I'm sorry to say I'm such an anti-smoker that I think whatever makes it difficult for you to smoke is probably a good thing.
Okay.
But you're right. This is a cultural. This is a culturally loaded
dream box
question.
The guy was out for smoking to the data center. It's also a good thing. I mean, but for the other side, right?
Well, you have a badge, and you should use your badge to walk out and walk in.
Yeah.
And if it's a good design, there should be a man trap at the exit, so only one of you can go in at a time, and someone can't tailgate in after you. But there is a benefit to smoking, despite what I've said about it, and that is that there's a lot of communication among the smokers, which is across the boundaries in the bureaucracy. So you'll find out all sorts of things about your company that you didn't know, and they will find out all sorts of things about your work that they didn't know, because you're all common addicts.
Okay, I have two other quick questions. Like, in challenge response systems, like with the electronic locks, you have a token with RFID, whatever. I heard that there are like man-in-the-middle devices, like a suitcase you carry with you. One you bring near to the guy with the token, the other one you bring right in front of the door, and they can exchange like remotely the challenge response thing.
Yeah, that indeed is true. I'm not sure if such a device exists, but at least in theory you could do it like that. If the people who implement the challenge response are halfway clever, they just take the speed of light for, say, 3 meters, and if the challenge to the response, or if the response to the challenge takes longer than the speed of light of 3 minutes or 3 meters, it's useless. So this should be a way to defeat it, but if it's actually done like that, I don't know.
Okay, I also heard that devices are around. The last one is like the area codes on the locks you showed us, like from Berlin, this 254, whatever it was. Is it just on the keys or is it also on the locks?
No, it's just on the keys.
Too bad.
Why?
Thank you. Because otherwise you just have to look on the locks.
Well, the thing is, if I see a lock in Berlin from this brand, 99 out of 100, if I go to the lock shop in that area, 9 out of 10 times, I will just get the correct blank.
Nothing keeps you from going to the lock shop and buying a lock, and then you'll have a lock. What could be bad? Sorry, you've been waiting a while? The man in the aisle here holding the microphone?
I think
oh, he's handing out the microphone.